This is the fourth SWL prep video. Today we're going to look at same three topics, getting us prepared for the SWL coming up in May. Expressions and operations, equations and inequalities, and functions and statistics. Start with expressions and operations. We've got a translating problem. This is set up as a multiple choice, so we're going to look for some key words. First off, so we've got a cubed root right here. And we've got a square root of y. And we've got the subtraction in the middle. So if we look through our answers, first answer says 5 multiplied by the square root of the product of 4 and x. Well, as we said, it's a cubed root, so that one's not going to be right. B says 5 multiplied by the cubed root, so we're good there, of the product of 4 and x. Well, if you look inside the cubed root, we get 4x. Product means multiply, so we're good there. Minus the square root of y. That looks pretty good to me. I'm going to go ahead and select that for now. Let's go ahead and check the last two. C, 5 multiplied by the square root. Well, once again, it's not a square root, it's a cube root. And then D says 5 multiplied by the cube root of the product of 4 and x. That's good. Minus the cube root of y. Well, we've said that's a square root, so that one's not going to be right. So B was the correct answer. Moving down to number 2. 2 and 3, we're dealing with polynomials. And with polynomials, you're always going to start with those boxes whenever you're doing multiplication, division, or factoring. Let me redraw this box if I can get this to look a little bit better. So when we draw our box, we're going to put first term 2x squared in the first box, the last term in the last box. Here we're dividing, so we're going to put x minus 4 down the side. That's what I was saying. What's going to go on the top to make this all work out? So we'll start with x. X times 2x gives me 2x squared. Move down to the negative 4. Negative 4 and 2 gives me negative 8. So we've got 2x plus 2, which should be our answer. But we want to go back through and double check. So we're going to multiply back in. 2x and negative 4 gives us negative 8. X and 2 and x gives us positive 2. If we add these together, we should get that middle term. If we do, we did it correctly, and then 2x plus 2 is the answer. If we don't get negative 6, we did something wrong, and then we got to redo our problem. In this case, negative 8 plus 2 gives us negative 6. That's our check. 2x plus 2 is our answer. Number 3, this is a factoring problem. Very similar to what we just did, but it's got an extra step because we're not given one of the factors. So we would start by looking for a GCF. There is no GCF here because our middle term is just 1x. So there's nothing in common here. So we'll put our first term in the first box, last term in the last box. We got to figure out what's going to go in these two boxes. Well, we'll multiply the first and the last, so 6 and negative 15. Excuse me, gives us negative 90. So we need two numbers that are going to multiply to negative 90 and add to positive 1. So you can start listing out numbers if you want. So for instance, 1 times 90, 2 and 45, 3 and 30. Or one of these guys has to be negative, so we'll make the first one negative. And keep going, and finally you get to negative 9 and 10. Well, negative 9 and 10 is going to do the trick because negative 9 plus 10 also equals a positive 1. So it needs to both multiply to give us 90 and add to give us that middle term of 1x. So I'm going to put a negative 9x in one corner and a 10x in the other. And now I can start taking out GCFs from each of the pairings. So 6x squared and negative 9x, both divisible by 3, and they share an x. 10x and 15 are both divisible by 5. 6x squared and 10x, both divisible by 2, and they share an x. Negative 9x and negative 15 are both divisible by negative 3. So my factored form should be 3x plus 5 times 2x minus 3. We want to go back and double check just to make sure we didn't make a simple mistake. 2x times 3x gives us 6x squared. 2x times 5 gives us 10x. Negative 3 times 3x gives us 9x. And negative 3 times 5 gives us negative 15. So we want to go back in and multiply just to double check and make sure that all the numbers come out correctly and the signs are in the correct place. Moving on to number 4. So here we're going to go into equations and inequalities. We're solving a literal equation for h. So we're going to set up our do-undo chart. What's being done to h? Well, h is being multiplied by that parentheses, a minus b, and it's being multiplied by 1/2. So the opposite would be dividing by the parentheses and multiplying by 2. So we're going to work our way up, starting with a. So we should have a times 2 divided by a minus b. Looking at our answer choices, C is the best choice. Number 5, we want to plot a couple points that fall on this line. Basically asking us to graph this line. So we want to take this, we want to convert it to y equals. So I'm going to rewrite this, just kind of flipping the order. 4x minus 3y equals -6. Start by adding 4x to both sides. I'm trying to get y by itself here. So I get 3y equals 4x minus 6. Keep the signs with the correct term. Divide everything by the number in front of y. And we get y equals 4 over -3 or -4/3 x plus 2. So I'm going to start at +2, put a point here at +2 on the y-axis, and then my slope is -4/3, so I'm going to go down 4 and over 3, or you could have gone up 4 and to the left 3. So all the question asked was for the 2 points, so you needed 2 of these 3 points. You didn't need to draw the line, I just did to show you that we're basically graphing this line. Make sure you converted it correctly, make sure your signs are correct, and make sure you put the points in the correct place. Number 6, we want to write the equation in slope-intercept form. So we need to start with the slope. So we've got a point -8, 4 and an x-intercept of -2. I'm going to rewrite that as a point so that I have x1, y1, and x2, y2. So we can start by finding the slope. So 0 minus 4, y minus y, over -2 minus -8. That gives me -4 over a +6. Remember that minus a negative turns into adding a positive. So I'm going to simplify this to get -2/3. So from here, we're going to start by putting it in point slope form. So using our first point, we're going to have y minus 4 equals to -2/3 times x minus 8, or sorry, plus 8, because we're subtracting a negative. And then we want to convert this to slope-intercept. So I'm going to start by distributing. I'm running out of space here, so bear with me. But I get -2/3 x, and then -2/3 times 8 gives us -16/3. And we just multiply across the top, so treat that as 8 over 1. 2 times 8 is 16. 3 times 1 is 3. And you can also do it on the calculator. The calculator will do this for you as well. And so we're going to add 4 to both sides, giving us -2/3 x minus 4/3. Number 7, we're finding the x-intercepts of this quadratic. Remember, the x-intercepts are the same thing as the solutions, the roots, and the zeros, so we're going to graph it and then look at the x-axis. So in doing so, we should see that it crosses twice. First point where it crosses is 0.628, and the second is 6.37. Now here, neither of these points is a nice integer, so you want to make sure that you plug in this equation as y1, and then for y2, you're going to set that equal to 0. Once you've done that, you're going to go in and do second calc, option number 5, which is your intersect command, and then use that to find your 2 intersections. Number 8, we've got a system. So what we want to do is we want to convert these to y equals. So if we convert them to y equals, we can go ahead and graph them. So I'm going to subtract 4x from both sides, divide both sides by 2, giving me a first equation is y equals negative 2x plus 9. Second equation, all we have to do is divide everything by 6, or by negative 6, giving us y equals to negative 2/3 x minus 1/3. So I've got two equations here. I'm going to graph them using my graphing calculator. Once again, same thing to the last question, we're going to do the intersect command, because the answer here should be where these two lines cross. In doing that, we see the intersection is at 7, negative 5. The question simply asks for the x value, so our answer would be positive 7. Number 9, domain. Those are going to be our x values. We have now entered into our last section, our functions. This is functions and statistics. X values, make sure we put these guys in order and we don't repeat. So negative 4, negative 2, 1, 3, 5, 7, and 9. Now here it was coincidence. These points are already in numerical order based on their x values. So you need to make sure that you double check and make sure your x values are listed in order and that they do not repeat. Number 10, identify the zeros. We've already done a problem similar to this. We're simply going to graph it, and then we're going to look for where it crosses the x-axis. Here you have two nice points. Those points would be x equals 5 and x equals 3. So very similar to what we just did up here in problem number 7, where we graphed it and looked at the x-axis. Or you can graph it and look at the table of values, for those of you that prefer to do it that way. Number 11, we've got a direct variation. Remember that our equation for direct variation is y equals k times x. So in order to pick 3 points that create a direct variation, there should be some constant value of k that when I multiply by x, I get y. So if we look at my points, I cannot multiply anything by 0 to get 1. So that can't possibly be it. For the second one, 1 times 4 is 4. For the third one, 2 times 3 is 6. 4 times 4 is 16. 5 times 4 is 20. 6 times, I think that's an even one. So 6 times 4.67 gives us 28. And then 7 times, well, that's also not a nice number, 7 times 4.57. Now to get those last two, because they're not integers, I'm just working backwards and dividing. So 28 divided by 6 gives me the 4.67. 32 divided by 7 gives me the 4.57. But we're looking for 3 points that all have the same constant value, which would be those 4 that all have that multiple of 4. Number 12, we're finding the standard deviation. So you're going to put all of this in list 1, and then you're going to go stat to calc, and you're going to select option number 1, which would be the one var stats. Once you've done that in one var stats, you're going to look for the symbol that looks like this, and it's got a little x next to it in your calculator. Remember, that's the symbol for standard deviation. In this case, the standard deviation is 7.087, or we'll round that to 88. It's 0.8 or 0.876. Final page, number 13, another statistics question. The average score for Bill's class was an 87 with a standard deviation of 1.3. So here's our mean and our standard deviation. The average score on the test in Rebecca's class was 84, standard deviation of 1.7. So we have two classes, one for Bill and one for Rebecca. Bill's z-score was 1.9, and Rebecca got an 88 on her test. Who did better? So we want to compare them. Okay? So when we compare them, we want to compare them using the z-score. So we already know Bill's z-score is 1.9. So let's calculate Rebecca's z-score. So her 88 was an x, so we're going to do 88. Make sure you subtract the mean for her class, which was 84, and you divide it by 1.7. And you get a z-score of 2.36. So Rebecca's z-score was much higher than that of Bill's z-score, which means Rebecca did much better than the mean. Bigger z-score means you're further away from the mean. Positive means that you are bigger or greater than the mean. So Rebecca scored better. Her z-score was 2.36. 14, we got two box and whisker plots. Each of them has 10 elements. So we want to figure out which of these following statements is true. What we want to do is look at each of these and figure out, okay, how do these 10 elements break down? If we split it up, that means there's 2, 2, 2, and 2, because each group has to have the same amount. And then there's 2 guys left over, so we want to make sure it's symmetrical. So the 2 extras are going to get placed on either ends of the box. So the second one, same number of data points, so it has to have the same exact setup. 2, 2, 2, and 2 with one guy on each, or one girl. Whatever the element is, I don't know what this data is, on each of the ends of the box. So here, if you look at your options, the only option here that makes sense is B. Since both data sets have 10 elements, the box of plot A and the box of plot B contain the same number of elements. Everything else here is going to be false. Finally, in 15, we're finding the equation for the line of best fit for the following data. So you're going to put the meal cost in list 1, the tip in list 2. Then you're going to go stat, calc, and then you're going to choose option number 4, which will be linear regression. So it's the line of best fit, so you're going to make sure you do linear regression. In doing so, you should get y equals 0.1437x plus 2.012. As always, if you have any questions, you can go back and rewind and rewatch the video, or you can make sure you make a note of those questions so the next time I see you in class, I can help you out and make sure you're going in the right direction.